What's up, guys? Day 88 of the 100 Days of LeetCode. We got a medium problem. Binary search tree iterator. It's another in-order traversal problem. Yesterday, day 87 was also something that we solved using in-order traversal. So that's the theme of these past 2 days. Let's do it. So we want to implement a BST iterator class that represents an iterator over the in-order traversal of a binary search tree BST. And this is basically going to be the initializer. It initializes an object of the BST iterator class. The root of the BST is given as part of the constructor. The pointer should be initialized to be a non-existent number smaller than any element in the BST. Okay. Now we have Boolean has next, and we want to return true if there exists a number in the traversal to the right of the pointer. Otherwise, return false. Int is equal to next, and it moves the pointer to the right, then returns the number at the pointer. And notice that by initializing the pointer to a non-existent smallest number, the first call to next will return the smallest element in the BST. You may assume that next calls will be valid. There will be at least a next number in the in-order traversal when next is called. This is basically just an example of sort of just an input. So first it constructs it, okay, and then it calls next, has next. It's all pretty straightforward. The only thing I would say is that obviously the last has next, it's going to return false because that's when it has already, nexted its way to the back of the, or not to the back, to the last node of the tree. And one thing it says, follow-up, can we implement next and has next to run an average O1 time and use OH memory where H is the height of the tree? Yes, we can do that. So the way we're going to solve this problem is in our initializer, we're just going to do the in-order traversal. We're just going to store all that in a list. And then we'll be able to just iterate through that list easily with next, and then we'll be able to check has next very easily as well. So we're going to write an in-order method. It's just going to take self as a parameter, and it's going to take a root as well, and the root is going to be an optional tree node. And what we're going to do is we're going to come back to that in a second. But up here in the initializer, we're going to create the list, and that's just going to be the list. And then we're going to create a self.curIndex. So this is where we're at right now in the list. And to be more precise, this current index is going to be the next index that we would return if we called next, right? So right now it's 0, meaning that if we called next, it's going to return the number at the 0th index, or the number that is the first number in the in-order traversal of the tree. So that's why we initialize it to 0. And then we're going to call self.inOrder, passing in our root as a parameter. So like I said, I've done a few in-order traversal problems. I'm just going to write it. I'm not going to spend too much time on this. But basically what an in-order traversal is we basically traverse the tree from left to right. So first we traverse the left subtree, then the root, then the right subtree. So in this example, the in-order traversal would be 3, 7, 9, 15, 20. So we want to get this into a list where the order goes 3, 7, 9, 15, 20. And in a binary search tree, the in-order traversal will be sorted. That's just another little fun fact. So let's do this in-order method. So the first thing we're going to do is we're going to check whether or not the root is none. And if the root is none, we can check for that by just saying if not root. If the root is none, we're just going to return. Now, if the root is not none, what did I say we had to do first? We have to traverse the left subtree. So we're going to simply call self.inOrder root.left. Now, after that, we want to add the value of the root to our list. So we're going to do self.thelist.append just root. And then after we visit the root, we want to traverse the right subtree. We can do self.thelist.append. Sorry guys. Self.inOrder root dot right. There we go. Okay, so now we've implemented our in order method. Next thing is the next. Well, we want to basically save our next value in just a variable. We can just call it val. We'll say val is equal to self dot the list at index self dot cur index. And again, we are guaranteed that next calls will always be valid, so we don't have to check anything in here. We can just do this, right? So we're never going to have a sort of index out of bounds exception there. And then we want to increment our cur index, and we want to return our val. Now, with the way I did it, basically we have to store our value at the current index before we increment it, right? Or else we'll be skipping sort of a spot in the list. And then after we save that value in a variable, then we increment the cur index, and then we return the value that we had previously saved. Okay, perfect. Now, the has next, this is just pretty easy. We're just going to check whether or not the current index is greater than or equal to the length of self.the list, okay? Meaning that if the next index, which this is basically what this is holding, right? By cur index, I mean the current next index that we'll be visiting in our traversal, or in our iterator, I should say. If this is greater than or equal to the length of the list, well, then we know that we don't have a next, right? Because the next will be a node sort of outside of the tree. Or not even a node outside the tree. There's just no node in the list there, right? So if that's the case, we're going to return false. If that's not the case, then we know we do have a node, or not a node, a value that we can iterate to, and we're going to return true, and we can submit our code. And that's because we need to put self.curIndex. Let's see what I did wrong here. Okay, so yeah, this is what I did wrong. We want to add the value, not the node itself, right? So if you notice there, we had all the values at the bottom, the expected, and then the output, we had sort of the information about the objects themselves. So yeah, we're only appending the value to the list. Sorry about that. But yeah, that's how you solve that problem. That was day 88. Tomorrow is day 89. We're almost done, guys. If you guys have been liking these videos, please like, subscribe. It means a lot to me. And yeah, thanks.